Okay, this question is a little bit special because it involves a thermocouple. So in class, I have explained to you how to use the gradient method to calibrate thermometers. But for thermocouple, it is a special case. Why is it so? Because if you read the question, it doesn't tell you at ice point what is the voltage. It only tells you that when it is submerged in 40 degrees Celsius water, you get 12 millivolt registered. So because of that, you cannot use the gradient method. So for thermocouple, you follow a special formula. So if you still remember your mathematics on directly proportional, actually for thermocouple, any change in temperature is directly proportional to the voltage that it produces. So if you forget about directly proportional, is okay, don't worry, your mathematics teacher will help you. So if you forget about this, then just remember this formula. So I will explain to you what this formula is. So for delta T, this guy represents the change, or should I say the difference, okay, in temperature between your hot end and cold end. So in another word, you can say that your delta T is equals to the temperature in the hot end minus off the temperature of the cold end. Now you have to stick to this formula consistently. If let's say the cold end temperature is a negative number and the hot end temperature is, let's say, 100, then this formula will be 100 minus a negative number. Okay, so this minus must be followed consistently because you are talking about the difference in temperature. That's why you have the minus here. So even if your cold end temperature is a negative number, you just plug in that negative temperature and stick to this formula. So this is what delta T stands for. This triangle is called delta, okay, and it means the difference in temperature. Now this K is simply a constant. So we will elaborate on how to find this constant in the next part of the explanation. This V, I think, is self-explanatory. It means the voltage, okay, generated because of this difference in temperature. So just a quick revision, your thermocouple looks something like this. It consists of a wire A, then after that you have your wire B, voltmeter, another wire B. So these are called the hot end and the cold end. So usually the cold end, you submerge it at your ice point, and then down here you submerge the hot end in the thing that you want to measure, the object you want to measure. So because of this, whatever temperature difference between these two will create a voltage down here which you can read. So from this voltage we can then deduce what is this delta T. Okay, so this is the background. So let's get back to the question. Okay, the question says this thermocouple register 12 millivolt, okay, when you have cold end at ice point and you will have a hot end at 40 degrees Celsius water. So from this information, we can work out our constant K here because we need to know the constant. So this constant K, okay, is characteristic to that particular thermocouple. So if I have so let's say I have been using thermocouple A to measure so on and so forth. Let's say sample 1, sample 2, sample 3, sample 4. The constant K will always be the same. Okay, because the constant K depends on that particular thermocouple. Okay, but if you want to change to another thermocouple, then you need to recalculate what is this K. So let's see how to get this K. So now we were told that this temperature difference is your hot end minus of your cold end, 40 minus 0. The K I do not know yet, but the question has told me that the voltage produced is 12 millivolt. 12 millivolt is around 12 divided by 1000. Okay, or if you are good at your prefixes, you can write down is 12 times 10 to the power of minus 3. So since you know this, you know this, you know this, you have only one unknown. You can then work out what is your k. So if you work out your k, it will become like this. And your k will be the same throughout for your part A and part B because the thermocouple is the same. So let's see how do I tackle the question A. So for your part A, okay, you will ask the cold end is in melting ice, the hot end now is in steam at atmospheric pressure. So when your hot end is placed in steam, basically they are saying that now your hot end is at 100 degrees Celsius and your cold end is still in ice, right? So it's 0 degrees Celsius. So with these two information, you work out your new difference in temperature is now 100 minus 0, which is 100 degrees Celsius. So far so good. Then you go back to your thermocouple formula. You now know that your delta T is 100 and your K, since you are using the same thermocouple, you can use back this value here, 40 over 12 times 10 to the power minus 3. And then you can work out what is your V here. Okay, this will be the answer for your part A. So for those who are not so good in manipulation, I will just show you how to manipulate this. So V, 100 divided by this factor will be 100 times 12 times 10 to the power of minus 3 over 40. Okay, so you just need to work this out and you will get the answer for your part A. I don't have a calculator at home, so I will leave the answering to you. Okay, now let's look at part B. Actually, the whole mechanism or the steps are the same. So now they tell you that the cold end is now no longer in ice point. Okay, and the hot end is also no longer in steam point. So if you read part B, your hot end is now at 60 degrees Celsius and now your cold end is at 40 degrees Celsius. So this will give you a different delta T. So down here, you just follow the same method. Okay, you will get 20 degrees Celsius. You notice that I purposely do my working in the same layout so you can see the pattern clearly. So again, once I find out what is my delta T, I code the formula. It's always good to code the formula because you will get working mark in case you make some silly mistake. So you plug in the same value. Now the delta T is 20. The K remains the same, okay, because you are using the same thermocouple. Okay, so this K I get from the calculation earlier on, okay, whereby I make use of the information given in the question at the very beginning to work out what is my K. Okay, if you forget where I get my K, rewind the YouTube video and watch it again. So again, I do my manipulation. Okay, I then can easily find out what is my answer. So this is your answer for part B. Now, I just want to give you a further example, your part C. If let's say now my hot end is still at 60 degrees, but now my cold end, I go and put it in some negative value. Let's say negative, let's make it even more difficult. Let's say at the hot end, I put the hot end at negative 60. Okay, negative 60. And my cold end, I put it as negative 140 degrees C. What will be my delta T? It's the same thing, okay? So delta T is my hot end, which is negative 60, minus my cold end, negative 140. So if you press the calculator, you will then get 80 degree. Can? So don't worry even if there is a negative hot end or negative cold end. Just follow the equation that I tell you at the very beginning on delta T. Just use temperature hot minus temperature cold. That's it. Okay, so remember thermocouple, you cannot use the gradient method which you use to calibrate liquid thermometer. Okay, it is a special case. You have to use this equation. Okay, good luck for your test.